Okay, this is a test review. A couple things I want to remind you about. I want you to remind you to use your highlighters. Okay, bring them in, physical highlighters for the test. So let's look at 7 and 12, angle 7 and 12. So 7 is here, and 12 is here. Now you can see that there's a line that they share. There's 12. There's a line they share, which is right here. We're going to highlight that one purple for you. It's the line that they share, and then there's two lines that they don't share, which we'll use the blue for. Okay? So every angle has two sides. So that angle and that angle, they have two sides. The sides they don't share are the blue, and the side they do share is the purple. And when that happens, we get an interior and an exterior, right? So this is the interior. All of this is the interior. This is the exterior. Okay? So when we look at angle 7, we see 7 and 12 are both in the interior, and they're both on the same side of the purple transversal. They're both on the same side. So same side interior angles right here. Same side interior angles. Okay, and then you start again. So we're doing angle 11 and 16. 11 and 16. So 11 and 16. And we're not going to do every one this. We're not going to spend this much time on every one, just to get you started. So 11 and 16. 11 and 16. Okay, there they are. So the line that they share is going to be purple. That's this line they share. And the two that they don't share are here and here. Okay, so let's take a look. Now, again, the interior's changed. Now the interior is here. So, when you look at 11 and 16, are they both inside the interior? No, one's interior, one's exterior. Are they on the same side of the transversal? They are. But they're in the bottom right. So that's corresponding. That's a unique one, right? Corresponding is when they're both in the bottom right, or upper left. One's interior, one's exterior. Okay, so that's corresponding. All right, we did the rest of these in class, so I'm just going to go very quickly. So 3 and 7 are on the same side of the transversal and same side interior, so that's SSI. 6 and 2. 6 and 2. 6 is here, 2 is here, so they're both in the exterior. This is one that's not going to be on the quiz, but it's good to know. SSE, same side exterior. 14 and 4. Clean up a little bit. So 14 and 4, 14 and 4. They're on the same side and they're exterior. So again, they're same side exterior. And 7 and 5. 7 and 5 across from each other. See, if you make the two sides here and the two sides here, they're across from each other. That's vertical angles, right? Vertical angles, very important. 9 and 12. 9 and 12 are next to each other. Together they make a straight, so they're adjacent and they make a straight line. Not all adjacent angles make a straight line, right? Here's two examples. These two examples here, angle, let's say 17 and 18. They're adjacent. They share this green side here. They're adjacent. They have the same vertex, but they're not a linear pair because they don't form a straight line, right? A linear pair has to go from here and then all the way to here. So not all adjacent angles are a linear pair. Okay, 9 and 12 are a linear pair. 8 and 11. 8 and 11, same side exterior again. Okay, and 10 and 1. So 10 has sides here and here. Angle 1 has sides here and here. Notice none of those lines are shared. Those are 4 different lines. So there's nothing going on there. Okay, really quick, to solve 18, right? I don't know what the relationships of these are. There's no name for it. So what I'm going to do is use relationships that I do know. For example, the big Z, right? When we talked about the big Z. That means alternate interior angles, okay? So that means that this is also 4x minus 5. Remember, that's only if the lines are parallel, only if lines are parallel. Okay, so now we know this angle, which is 4x minus 5, and this angle makes a complete straight line, so they're a linear pair. And linear pair angles are supplementary. and supplementary angles add up to 180 degrees. Okay, and of course we add like terms. Add 12 to both sides. Right, 16 goes into 192 if you're not using a calculator, one time. And that's 12. Okay? So this one, 19 is new. So we did a different one in class today. 19 is new. 19 is new. So we're going to do 19. We're going to do 19 as a new problem. So make sure you did that problem. If you didn't do this problem, because this is new on the new sheet, if you can download it. It's called version 1.3. Pause the video, do problem 19 right now, and then see if you can figure it out. Okay, so hopefully you gave 19 a try, either in class or just now. These angles are corresponding angles, okay? What do we know about corresponding angles? They are congruent, which means their measures are the same, so we're going to set them equal to each other. And that's a plus, just want to make sure, plus 29, okay? Now, it's true, excuse me, it's true that these are alternate exterior and they're equal too. But if you try to do that, well, look what happens. And I'm putting it in red on purpose to show you it doesn't work. If you try to do that, you get this. That doesn't work because you have an X and a Y. So although that's true, and you could write this is true, it's unsolvable. Whereas the green one is solvable. So we use this one first, then we're going to solve for X. Okay, so we're going to subtract 10X from both sides. Add 6 to both sides. X equals 7. And now we're going to plug 7 back in here. See, we're going to plug 7 in here. And that's 95. Minus 6 equals Y plus 5. Now it is solvable. Okay? And we're going to subtract, that's 89 plus 5. I think it's 94. So Y equals 94. Okay, so that's the answer to my problem. Right there. Okay, this one's very important. Don't forget this, the big Z. So anytime you see a Z, there's one Z. I'll leave that one. Okay. Where, and of course, very important, the top and bottom of the Z are parallel. That's what those symbols mean. Then you know the angles inside the Z. The angles inside the Z. For example, this angle and this angle. Those angles are congruent, right? So we know that Z equals 28, which is easy. 28 should be 28 degrees. Now there's another Z though. The Z goes both directions in this case. So there's also a Z here. Again, the parallel lines. Okay, there's the down and then across. I shouldn't have used the thick one, but you get the idea, okay? And the inside of that Z is congruent, right? So that means that this and this are congruent. See the blue Z? That's a regular direction Z, right? Both forward and backwards work. So Z, I'm sorry, not Z. I'm saying the Z, but I don't mean Z. I mean X, right? So X equals 31 degrees. Okay, and then don't forget, we learned this last week. We proved it, that the three angles in a triangle add up to 180 degrees. So 28 plus 31, the two angles we just found, plus something we don't know, which is Y equals 180 degrees, because triangle sum theorem. Okay, that's 59 plus Y equals 180. Okay, and Y equals 121. Okay, there's the answer to that one. Okay, here you also get a Z. You also get a Z here. You also get a Z. And what we also taught you to do is to extend the lines, right? So make sure, I'll use the straight line tool here. Make sure you extend the lines. So that's all I'm doing is extending these parallel lines here. And I'm going to extend the transversal. That's not that parallel, but it does work. I can fix it, okay. And then this line here. Okay, and then we're going to extend this line here also. Okay, by extending the lines, we make it look like our normal parallel line thing we're used to doing, which is like this, right? When we see this, we know all the relationships here. Right, 1, 2, 3, 4, 5, 6, 7, 8. So when we see these 8 angles, we know it works. So if you look over here, that's kind of what I see over there. right? It's the same shape. And I see that because I extended the lines. If I don't extend the lines, I won't see that. So if you look, for example, over here, this angle and this angle are corresponding angles. Well, that's what we have over here. See it? Right there and there. Okay? And over here, same thing. Bottom left, bottom left. So those are corresponding angles too. So when the lines are parallel, which they are, so when the lines are parallel, we know that corresponding angles are congruent. So we get this, and we get this. Okay? And just like before, the Z is the third angle in the triangle. Okay, that's 70, 87. Z equals 180. Okay, and we get 93 degrees. Or 93, really. Okay, let's go to the proofs. All right. So, of course, this is given. Everything that's written here is a given, of course. And we also know that the last step has to be angle 4 is congruent to angle 2. Okay? Now, what do you see here? Vertical angle theorem. All right, well, you got to go look at the vertical angle theorem. So if we go to sheet 3-S, and we look for vertical angles, here it is. We look for vertical angles. Right here. It says if two angles are vertical angles, then they are congruent. Okay, so we're looking for two vertical angles in the proof. Okay, well, there's lots of vertical angles in this picture, but we're dealing with angle 1, 2, and 4, right? So I'm looking for something that involves 1, 2, and 4. Well, there's no vertical angles there to that one. So it must be in this group here. And the only two vertical angles that are named are 1 and 4. There they are. And we're actually going to mark them congruent in the diagram. So that means angle 1 is congruent to angle 4. Okay, and then very easily, as we always know, we're going to use either substitution or transitive in most proofs. And sure enough, here it goes. It says if A equals B, and B equals C, then A has to equal C. Okay, that's called transitive property, and this is transitive of congruency, so you can't use substitution here. If it was equals, you could. Okay, you cannot use substitution, so let's make a big note for ourselves here, all right? We cannot use substitution. Cannot use sub right here because of this thing, because of this congruency. You could change these to measures are equal. We talked about that in class using parentheses. That would be okay. But even so, because it's the primary listing here and not the parentheses, you really should be using transitive property of equality. Okay, guys, let's do this last proof. Now, there's a couple of issues. This proof was incorrectly written, so I'm going to fix it now. And if you haven't done it correctly or with this corrected data, please do it. So here's the fixes, okay? This is wrong. I believe 1.3 online is correct, but just in case, even if you have version 1.3, which is the latest version, please fix the proof or double check it to make sure it's fixed. Okay, so this shouldn't say angle 1. This should say angle 3 is supplementary to angle 2. If it doesn't, fix that. And of course, that means the same thing down here, okay? This should say angle 2. Okay, and this should say the measure of angle 2 plus the measure of angle 3 equals 180 degrees. Okay, so this is all wrong. Okay, everything else is okay. So, first thing, make sure your problem looks exactly like this problem. If it doesn't, fix it. Just cross it off like I did and fix it in Notability. If it looks like this, like the green, you're all set. Either way, pause the video, do this proof, and then I will solve it. Okay? Go ahead and pause the video. Okay, so hopefully you've given this proof a try. So obviously this is given. And we're looking at linear angle theorem. So if we go to A-S, and we look at linear angle theorem here in green, it says if two or more angles together form a straight line, then their measures add up to 180. So their measures add up to 180. So a linear pair always has measures that add up to 180. That's different from angle addition postulate, if you remember. Angle addition postulate, and I'm making up some angle here, like 11 and 12, right? Plus, I'm just making these up. But remember, it always equals an angle measure. See, that's big difference. No 180 here. Angle addition postulate never equals numbers. Linear angle theorem always equals a number, and it's always 180. Okay, so if we look to our diagram here, we're looking for angles 1, 3, and 2. Which of these angles 1, 3, and 2 are linear angles? 1 and 3. You see those two angles? They make a straight line together. They're adjacent. Now they're next to each other, and the separation between 1 and 3, the separation between 1 and the separation between 3 makes a full linear pair. So linear pair is those two angles add up to 180. Okay? Now, if you look at this line, we go from here to here, it looks almost the same. Those two things are the same, everything's the same, but these two are different, right? These two are different. So what does that mean? That means we removed angle 1 and replaced it with angle 2, which is legal because of step 1. So that's called substitution, which we're going to abbreviate as sub. It's one of our biggest abbreviations. Okay, now this says, right, remember the if says, if two angle measures add up to 180, then those angles are supplementary. Where could that be? Let's look to sheet 3S. And we're looking for something that says then their angles, then they are supplementary, right? Then they are supplementary. So look through this whole column, pause the video, look through this whole column and see something that says then they are supplementary. Okay, so did you find something? Well, there's one down here, right? There's one down here, but that's if two lines are parallel. We're not given it, there's no parallel lines given to us, so that's not going to be it. But here's another one. Then they are supplementary. Okay, so if two angle measures add up to 180, did we have that on the previous line? Yes. Okay, let's actually color code this, right? So let's make this one green, and then we'll make this one blue, okay? So, does it say somewhere in our proof that two angle measures add up to 180? I think it does. Let's take a look. There it is, right here, this whole thing, see? It says, if this, then they are supplementary. That's exactly what's being said here, see? If you look back here, right? If two angle measures add up to 180, that's what we have. There it is in green. They have two measures add up to 180. Well, then you can say that they're supplementary, which is in blue. And we can go right back here to blue. That's true. So what did we just say? We just quoted the definition of supplementary angles. Okay, that's it. All right, let's try a third proof. Again, this is brand new, so copy it down into your notes. Take you a few minutes. Copy it down, put it in Notability or in your notes, and then try it. I'm going to give you one hint, and then if you want to try it, I will kind of give you some more hints later. But first, really try to give it a try. Angle bisector. So you're going to look up on 3-S. See if you can find on 3-S here. See if you can find something that says if it's an angle bisector. So try to look to see if anything on this page under the hypothesis says if it is an angle bisector, because that's what it's telling you. EC is an angle bisector. So see what that says, and whatever the then is, put that in here, right? It's going to go in here. Okay, go ahead. I'll pause. You pause the video and start it up when you're ready to go. Okay, so the first thing, of course, is given, as is the second one. Did you look it up? Let's go look at 3-2. What says if it is an angle bisector, right? If a ray or something else is an angle bisector, it's right here. If a ray, line, or segment is an angle bisector, okay, then this blue has to appear in our proof. Then the angle is broken into two congruent angles, okay? So then the angle is broken into two congruent angles. So if EC, if this is an angle bisector, if that's an angle bisector, that means it broke this into two congruent angles. So we can say that. We can say that this has two congruent angles. So we can say angle 2 is congruent to angle 1. And what did you just read off of that 3-S? What did you read? You read the definition of an angle bisector. That's the symbol for angle, don't forget, bisector. Okay, if we go back to 3-S, that's what it says. You're quoting this definition of an angle bisector. It says if on the previous line something has been declared to be an angle bisector, then the angle is broken into two congruent parts. That's what we said. We said if this is true, right? That's the if. You don't have to write these lines to solve the proof, of course. If that's true, then this is true. That's what that definition says. The definition says somewhere earlier in the proof, EC was an angle bisector, then I can say that two angles are congruent. And then hopefully you can guess this last line, right? What do you have? This is a classic thing we've always talked about. If A equals B and B equals C, then A equals C. Of course, it's not equals though, it's congruency. Either way, it's transitive. Okay, transitive property of congruency. You can write just transitive, that's acceptable, at least in my class. Okay guys, hopefully that's a big help. Don't forget to study all of the problems, redo all the problems you got wrong. Hopefully you starred them or made notes about them, and even try to redo these proofs again. That would be a big help. Okay, good luck tomorrow.